If you've ever looked into a kettle and seen a crust of white scale, it's easy to wonder whether hard water is somehow hard on the body too. It sounds plausible. Hard water is rich in dissolved minerals, mainly calcium and magnesium, and those minerals are literally left behind where the water evaporates or gets heated. But the key point is simple. Typical hard drinking water is not considered a health hazard, and the minerals in it, especially magnesium, may even offer a limited cardiovascular benefit. Beyond that, the picture gets much less certain. First, what hard water actually means. It does not mean your tap is full of suspended limestone particles. Hardness is a chemical description of dissolved calcium and magnesium ions in the water. The visible limescale people notice usually forms when water is heated, which changes the chemistry and allows deposits to form on kettles, boilers, and pipes. So the usual hardness categories are really about water chemistry and technical effects like scaling, not a built-in label of healthy or unhealthy. That distinction matters because public health guidance does not treat hardness as a problem in itself. The World Health Organization's position is that, at normal drinking water concentrations, hardness is not considered a health issue requiring a limit value. Water can contribute some calcium and magnesium to the diet, but it is not a substitute for a balanced diet. In other words, yes, your tap water may add a bit to your mineral intake. No, it is not a magic nutrition source. And even that small contribution varies from person to person. Two people living on the same street can get very different real exposures. It depends on what they eat overall, how well their gut absorbs minerals, whether they take medications that alter mineral balance, how their kidneys function, and something very basic, how much tap water they actually drink. Some people mainly drink tea made with tap water. Others mostly drink bottled drinks. So when researchers compare regions with harder or softer water, it is hard to turn that into a precise conclusion for any one individual. There is, however, a biologically plausible reason scientists keep looking at this question. Magnesium plays important roles in electrical conduction, heart rhythm, blood vessel tone, and many enzyme systems. Calcium is essential too. But biology is not a straight line where more is always better. If there is a benefit, it may exist within a range, not increase indefinitely with every extra milligram. A lot of the early evidence came from ecological studies. Researchers noticed that some areas with harder water seem to have lower cardiovascular mortality. That sounds intriguing, but these are map-based comparisons, and they come with serious limitations. This is where source criticism matters. Ecological studies are vulnerable to the ecological fallacy. Patterns seen in populations do not necessarily hold for individuals. They are also easily confounded by differences in income, smoking, diet, pollution, medical care, age structure, and even record-keeping. So those studies were useful for generating hypotheses, not for proving cause and effect. More recent research has tried to go further. A 2016 meta-analysis combined 10 studies covering more than 77,000 coronary heart disease deaths. Higher magnesium in drinking water was associated with lower mortality, with a pooled relative risk of 0.89. That points toward a possible protective signal. But the uncertainty is important. Heterogeneity was above 70%, which means the studies differed from one another a lot. So the result is suggestive, not cleanly consistent. A 2023 systematic review also found that higher overall water hardness might be linked to lower cardiovascular mortality. Again, though, substantial variation remained across the evidence. Reviews can tell us whether a correlation keeps showing up in different places, but they cannot by themselves establish causation. Repetition is not the same thing as proof. Some of the strongest data come from very large national datasets. In Denmark, researchers studied more than 4.2 million people by linking home addresses to local water magnesium levels. Very magnesium-poor water was associated with higher mortality after acute myocardial infarction compared with the highest magnesium group. That supports the idea that magnesium, at least at the low end, could matter for heart outcomes. But the same study did not find the same clear pattern for overall cardiovascular mortality or for stroke. So even within one huge dataset, the signal was outcome-specific rather than universal. In the Netherlands, a cohort of nearly 7 million people found that more magnesium in drinking water was associated with slightly lower coronary heart disease mortality. But the same analysis also linked higher calcium and higher total hardness to a small increase in overall cardiovascular mortality. That is exactly the kind of mixed picture that prevents any simple slogan from surviving contact with the evidence. The same complexity appears in newer data. A 2025 UK Biobank analysis followed about 324,000 participants for more than 13 years and recorded tens of thousands of cardiovascular events. Higher magnesium was associated with somewhat lower risk, while calcium and total hardness showed partly U-shaped relationships. In plain language, that means the healthiest range may not be at the extreme high or extreme low ends. Put all that together, and the strongest pro-cardiovascular argument is this. Repeated associations across large datasets suggest that magnesium, more than hardness itself, may be beneficial for some specific cardiovascular outcomes, especially coronary disease or heart attack risk. But the strongest argument against overclaiming is just as clear. Findings differ depending on the outcome, the mineral being measured, and the study design. Some are mixed, some are inconsistent, and some appear U-shaped. So it would be wrong to say simply that harder water is healthier. It would also be wrong to say the effects are proven causal. What about longer life overall? This is where the story gets more speculative. One often cited example comes from Japan's Amami Islands, where limestone bedrock and harder water were linked to a higher proportion of centenarians. It is certainly interesting. But 4 island regions are not a controlled experiment. Genetics, diet, social structure, and migration could all help explain the pattern. So the longevity evidence is suggestive only. Dementia is even less convincing. There is some background research linking low serum magnesium to higher dementia risk, while other studies suggest a U-shaped pattern. But it is crucial not to blur different kinds of measurements together. Serum magnesium, dietary magnesium intake, and water hardness are not the same thing, and they cannot be treated as interchangeable. One of the most relevant tests came after desalination changed the water supply in an Israeli city. Water magnesium became very low, and average serum magnesium dropped slightly. If water magnesium had a strong direct protective effect against dementia, you might expect dementia prevalence to rise clearly compared with a groundwater-based comparison city. It did not. A very small effect could not be ruled out, but there was no convincing direct evidence of protection. So where does this leave ordinary decisions at home? It means softening water is mainly a technical or taste choice, not automatically a health improvement. People soften water to reduce scaling, protect appliances, or change how the water feels. Those are practical reasons, not evidence that natural hard water is dangerous. And the scale in your kettle should not be imagined as an equivalent buildup inside the body. That is a misleading analogy. It also means these population-level findings do not support high-dose magnesium supplementation as a shortcut. The research is about modest differences in mineral content in drinking water across large populations, not about taking large supplements and expecting the same effect. Biology rarely works that neatly. The most balanced conclusion is probably the least dramatic one. Hard water at typical levels is generally unproblematic. Its minerals make a small contribution to intake, but they do not replace good nutrition. Magnesium shows moderate but inconsistent cardiovascular signals, especially for coronary outcomes. Yet causation is not proven, and no clear optimal level emerges from the evidence. Claims about longer life remain suggestive rather than established, and dementia protection from hard water lacks convincing direct support. So if your local water is hard, the current evidence does not say you should fear it. If anything, the research offers a cautious reason to think that magnesium in drinking water may sometimes be helpful for the heart. But cautious is the key word. The science does not justify turning hard water into a miracle health trend, and it does not support the opposite myth that it is silently harming people simply because it leaves marks on a kettle. Subscribe, enable notifications, and tell us in the comments what topic we should explore next.